Next up, we're going to talk about the connected vehicle training framework and lessons learned to improve safety of highway patrol troopers. And we do have a change in the speaker from what is in your program. It is updated online if you're following the online agenda. But we'll be hearing from Sharif Gawi, postdoctoral research associate at the University of Wyoming. And he is also the deputy director of the Center for Simulation and Human Factors for Connected and Automated Vehicles. So Sharif, if you are online, if you could unmute yourself.
Hi, everyone. Thank you for your introduction. And today I'm going to speak about the connected vehicle training framework and lessons learned from the CV pilot to improve the safety on one of the populations that uses this technology, which is the highway patrol troopers. So according to the National Highway Traffic Safety Administration, 94% of traffic crashes are a result of human errors. And we do have a yearly crashes, fatality crashes, more than 36,000 fatalities per year in our roadways here in the US. And if we are talking more specifically on police troopers, we do have very few studies that consider their safety. And according to the FBI, law enforcement officers killed and assaulted, the LEOKA, we do have, or they reported that there are nearly 95 police officers were involved in fatal crashes for motor vehicles. This was between 2015 and 2017. So we need to conduct this study in order to enhance the overall safety and traffic safety for police troopers. So the US Department of Transportation, the US DOT, has deployed a CV pilot program in 3 locations. One of them were here in Wyoming, in which the main focus in this pilot here in Wyoming was to enhance the overall safety and mobility for commercial truck drivers, as well as police troopers and snowplow drivers. These are the 3 fleet partners that will have these technologies equipped in their vehicles. With the main focus, again, to enhance the overall safety and mobility, using dedicated short-range communication and satellite communications as well. We do have 3 phases in which we are currently in the 3rd phase, starting with the planning, then deployment. After this, we have the demonstration, which we are currently in, which is mainly deploying or equipping the vehicles and the fleet partner vehicles with these CV technologies and the HMIs, the human machine interfaces, to communicate such real-time information about the upcoming hazards events that they might encounter due to weather events, rerouting events, and so on. And this is a real-world demonstration where we collect data in order to have further analysis and to evaluate the efficacy of this CV system or the CV technology. The corridor where the CV pilot is deployed is the I-80 corridor, 402 miles in Wyoming. The issues of I-80 is well known for Wyoming Department of Transportation. That's why it is one of the most instrumented rural corridors in the US. It has nearly 136 variable speed limits, 54 electronic message signs, 44 weather stations, and 52 webcams. These incorporated ITS technologies would help in enhancing the overall safety again on this corridor. On top of that, we do have this CV technology and CV pilot on the same corridor. We use different communications between the RSUs or roadside units and the vehicles. We do have V2V, vehicle to vehicle, vehicle to infrastructure, infrastructure to vehicle to communicate real-time information, again, about the hazards that they might encounter. We do have commercial vehicles, snowplow drivers, and police patrol will be equipped with these human-machine interfaces and communicating the information with the roadside units to enhance the awareness or situation awareness of drivers. The suite of applications that are going to be or that are incorporated within the CV technology starts with a forward collision warning. We do have situation awareness groups, distress notifications, work zones warnings, and spot weather impact warnings. These 5 groups form the different notifications that are going to be communicated within this corridor and within the CV pilot. the different traveler information messages, or these 5 groups, are going to be communicated using a display, which is the HMI, or the human machine interface, that will be or that is already mounted in our fleet partners vehicles, commercial trucks, police patrol cars, and also snowplow cars, where the design of this HMI was designed in a way to provide like the most important information on the far left side of the screen, where we have these regulatory speed limits and also the distress notifications. And the forward collision warning is in the middle of the screen, where we have these 2 levels of warning, the red and the yellow, where it triggers within 10 seconds for the yellow and then 5 seconds for the red notification for the forward collision, with this imminent sound to alert drivers if they are going to be involved in any forward collision event. And other notifications are placed according to their importance, whether they are in the middle of the screen for critical warnings, and advisory warnings are on the far right of the screen. Going back to our focus for this study, which is mainly the highway patrol, we do have 210 Wyoming state troopers covering nearly 6,800 miles of roadways, rural roadways, highways, state highways, and interstate roads. They do their daily job in such challenging environment. They have lots of equipment that they need to deal with on hourly basis. They do have this MDT, they have a siren, they have the radios, they have like all of these equipment. On top of that, we added this HMI, or the human machine interface. So all of these different activities that they need to engage while doing their regular job, or being involved in any pursuit or any event, this would provide an enormous workload on them while doing their daily job. That's why we believe that the CV technology might help them to increase their situational awareness and warn them with upcoming hazards, and this would help in adjusting their driving behavior and expectancy for the upcoming events that they might encounter. This study, we do have these 3 main objectives, starting with designing the training framework, where we have several tasks beneath it. And we do have the evaluation of the HMI to see the efficacy of the CV pilot. And finally, the recommendations. Sure, we went through different and several iterative steps to develop the training framework. For sure, we are dealing here with a specific population, which is police troopers. Somehow they are different, or not somehow, they are extremely different. They are really talented, they are really capable of controlling cars. So that's why we need to develop the training scenarios as well as the driving simulator several times to provide an efficient training framework that at least makes sense to them and train them for the CV technology. We conducted several focus groups, several mock-up trainings, and also surveys to come up with the training framework. And most importantly, we did like a couple of ride-alongs with 2 police troopers. We had 2 of them for 2 hours. This actually helped us a lot in order to understand the driving environment that they are involved in daily, which we mimicked and simulated in our driving simulator as well. We did like further analysis on these ride-alongs to identify what are the different activities that they are engaged in mostly. And among these different activities, we find that the interacting with the MDT, the mobile data terminal, which is the computer on their side, and also the radio and the siren box. These are the most 3 activities that they are engaged in. That's why we needed to simulate and integrate these 3 different pieces in the simulator that we have. So we added like a siren box in the steering wheel for our driving simulator, as well as the MDT and the radio. All of these different components were integrated using programming, which took lots of time, but like again, it will serve the overall training that we needed to do. And also we added the human machine interface, which is a display, a cell phone, or a tablet. It depends on the vehicle we are conducting the study on. And I would just like play this video just to give you a general idea about the simulator and about the study. As you see, we do have lots of notifications in MDT, and they need to interact. At the beginning, he was talking in the radio. We have these radio noises that they need to reply to, or like provides them with some information. We do have this eye tracking system. We do have some eye tracking system over here, which is mainly to identify where exactly the police officer or the participant is looking. Here is the eye tracking to identify the workload and so on. And as we see here, the HMI, it will display like these notifications where we tested several modalities, as we will see in the rest of the presentation. Okay, so this is just a quick video. So for the training framework, we started with a warm-up scenario and then some mini scenarios where we focused on a specific application, and then the comprehensive training where we combined several notification and travel information messages to mimic like a real life event that they might encounter. This one shows the slippery road scenario, and there is another one for work zone scenarios as well. These are the two layouts that we used. To have an idea about the general framework, this is the flow chart represented the training framework that we followed, starting with the preparation phase where we collected some basic information about the demographics and driving habits for them, for the participants. And then the initial training phase, again, where we conducted like on one specific application, and then the comprehensive where we combined different applications and tested different modalities as well. The modalities that we tested started with the baseline, which we don't have any HMI to compare the difference in performance between the CV and non-CV. Enlarged icons, where we have this enlarged icon, which goes back in the regular size again after 5 seconds. And then the e-voice, which is again enlarged. The difference between them, here we have a beep. In the enlarged voice, it just speaks the or says what's the content of this message. So for example, icy road or stuff like this. And then the fourth modality that we tested, which is the small icons, which are presented here just as this small icons on the screen. And for sure, the beeps and the e-voices are presented in a salient mood to alert drivers with the upcoming events. For the participants, we invited 10 police troopers, which represents nearly 5% of the total population of the WHP population, the Wyoming Highway Patrol in Wyoming. And here we can find like some basic demographics, the average working hours for them, years for them, and the miles driven and so on. And this experiment took nearly from 3 to 4 hours to conduct the full experiment. It was really lengthy, and that's why it needs to be interactive and attractive to them as well. We did further analysis from the driving simulator vehicle dynamics. This figure shows the average speed profiles of all participants. The mean speed of the baseline or the non-CV scenario, which is marked with the black line, it shows that it's always higher, and it has high fluctuation in speed for baseline compared to non-CV, to CV scenarios. And also, for sure, like troopers will always speeding above the speed limit to respond to the events or to the dispatch that they received. In the work zone baseline, which is shown in this figure, 2 participants actually were involved in a forward collision crash or event, and the rest of them avoided them. However, they did like an abrupt braking. And in these CV scenarios, they were able to avoid the forward collision. And if we come to the slippery road, 4 participants actually slipped in the 4th curve here. In this 4th curve, 4 of them slipped out or like had a run-off crash, and the others like managed to go through the scenario. However, again, for the CV, all of them were able to pass through the curves without getting involved in any crash. The summary or the findings out of the training. So again, the police patrol are really different from regular drivers. They are really capable. Like from the slippery road scenario, I designed these scenarios myself. I was not able to negotiate one of the curves at a speed above the speed limit. However, for them, they were above the speed limit by maybe 10 or 15 miles per hour. And again, they managed to go through it. So they are really capable. And again, we had to do this training several times and modify them in order to have an efficient training. Again, we cannot force them to follow the speed limits because again, they are responding to specific events that they need to speed to have a timely response. The overall training took nearly 3 to 4 hours. That's why we had to make like an interactive and attractive one. Regarding the performance, most of the participants appreciated the CV technology under poor visibility, not in clear weather, under poor visibility. This was like the preferred weather events where they want to see the CV technologies. Among the different applications, forward collision warnings was the most preferable application for police troopers, and rerouting was general for commercial drivers as well. Nearly 25% of the participants claimed that it might provide some distraction. However, we had a couple of studies going on right now and a couple of studies published already that identified the distraction from the HMI, which it is minor, so it did not provide distraction to drivers. General recommendations, most of the police troopers requested to have like a customizable capability. They need to identify what type of notification that they can see or they need to see, and what are the minor or like the unneeded notifications that they do not want to see. This was one of the recommendations that we provided to the START. By this, I end the presentation. Thank you for listening. And I thank my co-authors for this study, Dr. Ahmed, Dr. Yang, and also Biraj for conducting this study. And I would be happy to answer any questions. Thank you so much.
Great, thank you, Sharif. Really interesting information, a lot of very valuable information too in terms of trying to improve safety for those patrol troopers out there on the road. Any questions here in the audience? And Dustin, do we have any online?
I am not showing any.
Great. I know I found that a little bit interesting, Sharif, when you were talking about the differences between trooper drivers and just regular car drivers. And I'm kind of curious. I know you guys have also done some work with CMV drivers as well. Is there some differences between CMV drivers and trooper drivers in terms of your scenarios and your training and what you've seen?
Yes, for sure. So we did like studies as well for commercial truck drivers where we used our other driving simulator, which is a commercial semi-trailer. And for sure, the scenario itself and the training was extremely different. So in terms of the vehicle dynamics itself, so here we are simulating a police trooper car. We need to have like high acceleration, high speed, and the scenarios needs to accommodate for this variation. However, for truck drivers, the speed acceleration is extremely different. Again, the performance between the two populations is extremely different. The response, truck drivers as well, they are capable drivers, but again, the vehicle dynamics itself, it is different. So that's why we need to account for this in the driving simulator. For the training and the e-training, for sure we had like other applications that we need to train the commercial truck drivers on, which is mainly, for example, the rerouting and the parking rest areas, the information about the upcoming rest areas as well. So these were the main differences. And in terms of results, for sure, the police troopers is like they managed to control the car. Like, for example, as I said, for the slippery road scenario, we had 4 of them only just slipping out of the road. However, for commercial truck drivers, nearly all of them slipped off the road for the baseline. But like with the CV, all of them managed to went through the driving scenarios.
Great, thanks again. Any questions? Very interesting. It's always interesting seeing those simulators. They're very realistic.